Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today for exam IFM. For two European call options, call 1 and call 2, on a stock you are given the delta of call 1 is 0.5825 and of call 2 0.7773. Gamma of call 1 is 0.0651 and gamma of call 2 is 0.0746 and vega of call 1 is 0.0781 and of call 2 is 0.0596. Suppose you just sold 1,000 units of call 1. Determine the number of units of call 2 in stock you should buy or sell in order to both delta hedge and gamma hedge your position in call 1. You will create a delta hedge if you hold a position that will offset the movements of the original position you sold, so that the net effect on your combined position is zero when there are changes in the value of the underlying. We only delta hedging, gamma hedging, meaning that we take into consideration delta, the derivative of the price of the derivative security with respect to the price of the underlying, and gamma, which is the second derivative of the price of the derivative security with respect to the price of the underlying. So what we want is to create a position that has the same delta and the same gamma, and the original position we sold the call 1, so we are short that, and we're going to be long a position that has the same delta and gamma. So let us denote by Y the number of units of stock we will buy, and by Z the number of units of call 2 option we will buy. We don't necessarily assume that these are positive. If they turn out to be negative, that means we don't buy but we short, but otherwise just basically set the two equal to each other with respect to delta and with respect to gamma. So using delta neutrality, so having the delta of both positions being the same, the delta of 1,000 units of call 1 is 1,000 times 0.5825, and the delta of Y units of stock and Z units of call 2 will be Y times 1 plus Z times 0.7773. And using the same argument for gamma neutrality, we'll have 1,000 times 0.0651 equal to Y times 0, the second derivative of the price of the stock with respect to the price of the stock itself is 0 because the first derivative is 1, plus, which we used in the first equation, by the way, Y times 1 represents that, plus Z times 0.0746. And so from the second equation, we solve it immediately for Z, which turns out to be approximately 872.654. And actually this immediately tells us that B is the right answer. We also have Y equals approximately 1,000 times 0.5825 minus 872.654 times 0.7773. That's approximately negative 95.8, so we would short the call 2. Y is the number of units of stock. So it would be short the stock and long 872.7 units of call 2. And answer B is the choice. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.